ghee loaded sarson da saag and makke di roti. It's time to now fuel our intellect. Let's dive into a mind-boggling session with renewed energy as we continue exploring the latest advancement in medical science. We move to one of the most awaited event, that is the panel discussion on generative AI, a rapidly growing field with vast implications for medical education.
We welcome our esteemed chairperson, Brigadier Rakesh Datta, who is an accomplished medical professional with MS in ENT and a diploma in hospital and health management and medical law and ethics. In the field of medical publishing, he has been the past editor-in-chief of both MJAFI and Journal of Laryngology and Voice. He is also a member of the World Association of Medical Editors. His exceptional contributions have been recognized many a times. His areas of expertise include laryngology, biomedical publishing, and the adoption of innovative technologies in medical practice. I request the chairperson to please take over the proceedings.
Thank you.
Thank you, sir.
So, welcome back. I think now we are left with people who are going to talk. Okay. So I hope more and us will interact with each other, and we'll now come a bit to brass tacks and talk about various aspects. So the first aspect we're talking about is Gen AI. So we have three speakers. Can we just flash the first speaker's topic as well? I don't know the topics, by the way. They will just tell me the topics. So to begin with, what we will be doing is talking to them, and I will be joining along, and along with one surprise participant, and that participant will keep on when you want, and that participant will be a Gen AI agent. Okay, so that agent will also contribute and ask questions, and that Gen AI will also answer questions. So let us see who is able to contribute better or more when it comes to this particular topic. And the first person, of course, is a very dear friend, is Praful Mohan, and I'll request Praful to kindly come up. Praful is from FMC, and he's had a wonderful, multi-talented exposure in this particular field, and he's actually a very creative person. And thanks to his initiative is one of the reasons why we are having this conference today. So without wasting too much time, I'll ask him to introduce about Gen AI and more. And I'll request all the participants to keep their questions ready. And it may be sounding very simple or something. And at the same time, address it immediately. I'll ask them to be tightly brief so that we can have more time for discussion. And Praful, please, the stage is yours. I hope you don't mind not reading out the entire bit. Yeah.
So thanks a lot, sir. So actually reading out the entire bit is frankly not required, because what I would want the crowd to focus on is what I am going to talk now. So can I have my slides, please? So ladies and gentlemen, I know it's a post-lunch session. Even I am feeling a little sleepy, but I'll request you to be with me for some time. Bear this topic for just about initial 4 or 5 slides. And after that, I assure you, you won't be able to sleep even if you want to. Yeah, so this we all know. There are galore of a plethora of definitions of artificial intelligence. I'll again not go into the details of that. So it's an over-encompassing term which involves machine learning, deep learning, generative AI, natural language processing, so on and so forth. So with this infographic onto the right-hand side, I'll just try to inform the audience. I'm sure a lot of you already know about this, that what is essential difference between machine learning and deep learning. So machine learning, you label an item that it's a car, it's not a car, it's a car, it's not a car. And sometimes down the lane, machine is able to tell whether it's a car or not a car. But every time you have to annotate. While it comes to deep learning, something which you see here is a neural network. We are going to refer to this term multiple times, and this is the backbone of what we are going to talk about today. So you tell the system once that this is a car, this is not a car, and then you just feed in lots and lots of pictures of various vehicles, and then you ask it again, are you able to differentiate between a car and not a car? It will be able to differentiate for some times, for some frequency, and then again you tweak it, you train it. It's like teaching a child. It's essentially like teaching a child. It picks up cues from you, then you try to tell the child what's appropriate, what he's doing good, what he's doing wrong, so and so forth. Machine learning was simple tasks. Deep learning is for little more complicated tasks. So even if we just get this, that's good enough for us to go ahead. This is how it goes. So you feed in some data, your machine learning system learns something, which may not still be the best. You may want it to learn little better and come up with more predictable answers. Ideally, it should always tell you whether it's a car or it's not a car. It can happen, but it usually doesn't happen. So algorithms, they have their own limitations of functionality. But then you again try to, give more data to it. And over a period of some cycles, the algorithm learns. How much it learns is basically dependent on what is the F1 score. Without going into the mathematics of it, suffice to say that it ranges between 0 to 1. 1 is perfect. If somebody shows me a picture of a car, I'll certainly be able to tell that it's a car. So my F1 score is 1. Very difficult for machine learning or AI algorithms to achieve a level of 1. That means it's a fully developed, dependable AI model. Generally, it hovers around 0.8, 0.9, whatever it is. So 0, of course, it's not able to tell at all. Now, what happens? What's the difference between traditional statistical methods, small neural networks, and large neural networks? Just bear this term in this manner for another 2 slides, and then we're going to talk about neural networks. Essentially, if you increase the data size, the learning does not increase beyond a point. So it's not that you keep on feeding data, and your algorithm will reach a F1 score of 1. It may not, it will not probably. But when you are working with more complicated systems, then they keep on optimizing. But they also do not reach a level of F1 score of 1. So now with this small background, let's come to generative AI. Generative AI, basically, there is something known as natural language processing, which can convert your text, your video to audio. It can read these things, various multimodal inputs, and it can extract certain information from them. It can depict some relationship between these two things. Basically, NLP is something which reads your text, videos, and audios. Now, coming to generative AI, as the name says, generative, it creates new contents. How? By using artificial intelligence, specifically neural networks and deep learning, because it's a complicated task. So if I were to say in Hindi, it's the difference between patana and banana. So machine learning or a normal AI will tell you, but a generative AI will make it for you. That's the function. That's the essential difference. Now let's just come to this neural network, and I'll take the analogy of a kitchen. And we'll take this analogy right till the end of my slide. So let's say, essentially, these are algorithms who are connected to each other in multiple ways. Some of it is known to us, some of it we don't know. A lot of it we don't need. So you just see that it's a kitchen. What we feed inside the kitchen is vegetables, flour, salt, something. And then we do something with that, and what comes out of it is the dish. It's as simple. Why do we call them a neural network? Because these algorithms are connected to each other like the neurons in the brain. So one thing which stands out is the quality of the product will also depend on what was fed inside. That's the importance of data. Second is, are we interested in how it is being made? Or are we interested in how well it has been made? How many of you feel that it is important to know exactly how it is made and not how well it is made? Any show of hands? Or are we sure that we are more interested in the output than the process? It's the output, right? So we are actually interested in the dish. Now, let's come to another term, which is known as parameters. It is a very important term, and we see why important it is. So basically, the more number of algorithms connected to each other we have, the more number of parameter that neural network is supposed to have. So this is a very simple, small neural network which has just about 99 parameters. And how they have been calculated, I've already shown for ease of simplicity, right? Okay, so you can also say, if I take the analogy of kitchen, you can also say that 99 things you are doing inside. One of them may be cutting the vegetables, one of them may be cleaning the vegetables, one of them may be simmering, sorting, whatever it is. So these are the 99 acts which you are doing to the raw material which was given to you. And all these things are dependent on each other. Unless you slice the vegetable well, you won't be able to saute it. Just to give you a simple example. So what we have in front of us is a very simple neural network. So let's say I have called. Is my boss there? Okay. So I've called my boss to my home for dinner. I tell my wife that please make 4 dishes. So she makes 4 dishes. And the success of the spread would lie how each of this dish is made and how those dishes are relatable. So if I have the sarson ka da saag, I also need to have a makki di roti, right? Okay, but my boss likes sweet dish more. So I'll give more preference to the sweet dish. कि भाई यार ये ठीक बननी चाहिए. बाकी तो वो ठीक है, वो दाल वाल नहीं खाता, वो sweet dish बढ़िया बनाओ. So that means I'll give more importance to one particular dish out of the whole spread. So that's the weight a particular node will assume in that entire sequence of things. Now, what is the bias? Bias is something which you would do to every node. Let's say my boss likes chili more. वो मिर्च ज़्यादा खाता है. So my bias in terms of neural network would be put more chili in each dish. So I am tweaking the entire thing to be more spicy. Now this is something which I'm doing to everything except the sweet dish. And what I get is the dish. Activation function can be the process of laying it out. And what I have at the end of the day is a dish. Tomorrow, if my mother-in-law comes and she doesn't eat spices, she doesn't like spices, then I'll remove this bias. Right? I hope we are sort of there, if not completely there. So this is what a parameter, and how do we tweak parameters to come up with something what we want, right? Let's go ahead then this. Now coming to what language model is. Language model is very simple. It's a neural network which predicts the word which is likely to follow. So if I say the color of the sky is 91% of the times, this neural network will say blue. It may also say gray. Where is this information coming from? How does it know it's blue? Because it has read a lot of books. A lot of repository of literature has gone through this neural network, and now it understands if I say the color of the sky is, most of the times it will be blue. So it comes out with blue. But it only does that for 91% of the times. 9% of the times it may throw up a wrong answer or something which you don't require. Okay, so let us take this iterative example. If you were a language model and I say Pune is, what would be your word? Anyone? Next, Pune is city. Okay, Pune is city. Another neural network can say Pune is awesome. Most of the times it will be city, because most of us will